Assalamualaikum warahmatullahi ta'ala wabarakatuh, and hi everyone. In this video, I will discuss the solution for SCORE PHYSICS SET 3 from Program Kecemerlangan Akademik Unit Fizik Kolej Matrikulasi Negeri Sembilan. In this video, I will discuss the solution for question number 1 to question number 5, or from topic 1 to topic 5. Question 1. Impulse-momentum theorem states that the impulse J of a body equal to the change of the body's momentum given by J is equal to delta P. Momentum is defined as the product between the mass and velocity. Determine the dimension and SI unit for impulse. Before we find the solution, take a look. We recall back what you have learned before, especially when we want to write down the dimension equation referring to the physics equation. So let's say if we have the additional and subtraction operation, so the way we write down the dimension equation is, for each item inside the equation, the dimension is equal. For the multiply and division operation, so for the dimension equation, we need to multiply and divide the dimension. Because of that, referring to the question number 1, we have the equation of impulse-momentum theorem, which is J is equal to delta P equal to mv minus mu. When we want to write down the dimension equation, so you can write down that the J, the impulse, the dimension for impulse is equal to dimension of m times with dimension of v equal to dimension of m times dimension of u. Because of that, the dimension for m is capital letters of M, dimension of v is LT minus 1. So we get the dimension for impulse MLT minus 1. And then to identify the SI base unit, just to recall back the dimension for each physics quantity, the symbol and also the unit as shown in the table. Referring to the dimension of the impulse, we can state that the SI unit for impulse is kg m s minus 1. For question 2a, when you read the question, at the same time, list all the information given from the question, include the hidden info. For example, referring to this question, a car which is initially at rest. So initially at rest, meaning that the initial velocity is equal to 0. Start to move along a straight line with a constant acceleration. So A is equal to constant. It reached a velocity of 60 meters per second. So 60 meters per second is the final velocity after traveling through a distance of 100 meters. So S is equal to 100 meters. You need to determine the acceleration and the time taken to reach the velocity of 60 meters per second. First, to calculate the acceleration, referring to all information that you have stated here, we can use equation of v square equal to u square plus 2as, and substitute the value, you will get the acceleration, which is equal to 18 meters per second. For the time taken to reach the velocity of 60 meters per second, find the equation that there is t inside the equation. So in this case, you can use equation v is equal to u plus at, and then b is 60, u is 0, a we have calculated earlier, which is 18. Then you can calculate the t, which is time taken to reach the velocity of 60, equal to 3.33 seconds. Question 2b. Figure 1 shows a cannonball is fired horizontally with a velocity of 150 meters per second from a 100-meter fortress. Before we calculate, take a look just to recall back, because of this question is related to the projectile motion, and it is a half projectile motion. So referring to the half projectile motion, we get few hidden information, such as the first one is our ux is equal to 150 meters as stated in the question. And then uy is equal to 0 at the maximum height. Sy is negative 100 meters because of when definition of displacement is from initial to final point in the straight line. So referring to this vector, we resolve s to the sy and sx as shown. That's why we get the sy is negative 100 meters because of the direction is downward. For question number 1, we need to calculate the magnitude of resultant velocity of the cannonball 20 meters from the ground. So where is the position of 20 meters from the ground? Referring to the diagram, okay, the 20 meters from the ground is also represent the negative 80 meters from the top of the fortress, or from the position where the cannonball is fired, okay, as shown in the diagram. And we want to calculate the magnitude of resultant velocity at that point. So to calculate the magnitude of resultant velocity, you need to know the Vx and Vy. And well known for the projectile motion, Vx is always equal to Ux. So Vx is equal to 150 meter per second. For the Vy, you need to calculate the Vy by using equation of Vy square equal to Uy square minus 2gs. Substitute Uy, which is equal to 0 at the maximum height. G is 9.81, negative 9.81, and the displacement is negative 80. You will get that the Vy is equal to 39.62 meter per second. After you get Vx and Vy, then you can calculate the resultant velocity. The magnitude of the resultant velocity is equal to 155.14 meter per second. Question 2, you need to calculate the time of light when the cannonball reach the ground. To calculate the time of flight, you can use the equation of Sy is equal to Uyt minus half gt square. Our Sy is negative 100, Uy is still 0, and G is negative 9.81. When you calculate the T, you will get the T is equal to 4.52 seconds. And question number 3, you need to calculate the horizontal range when the cannonball reach the ground. So the equation for the horizontal range is Sx, represent the horizontal range, equal to Uxt. Our Ux just now is 150, and T we have calculated in 2, which is 4.52. Because of that, you will get that the horizontal range, or Sx, is equal to 678 meter. For question number 3a, an object of mass 4 kg, which is initially at rest, is acted upon by a force F that varies with time t. Okay, referring to the first statement, we know that the mass of the object is 4. Just list all the information given. And initially at rest, meaning that the U is equal to 0 meter per second. You need to determine the change in momentum acquired by the object. Referring to the graph given, which is graph F versus T, we know that from the graph F versus T, the area under the graph is represent impulse. And from the impuls-momentum theorem, we know that the J is equal to delta P, or change in momentum. Because of that, if you want to calculate the change in momentum referring to the graph given, so it is also equal to area under the graph, equal to half times with the height of the trapezium 14 times with 4 plus 7. You will get that the change in momentum referring to the graph of F versus T is 77 kg meter per second. Question 3b, figure shows two balls, A of mass 8 kg and B of mass 6 kg, move with the velocity UA and UB as shown. Both balls collide and combine at O, then travel with the velocity V. By referring to the principle of conservation of momentum, determine the velocity V. First, identify the situation before and after collision. And then, if you refer to the diagram, V is not at the x or y component. So, of course, there is theta here, and we can resolve V into Vx and Vy. We will use the principle of conservation of momentum. So, total linear momentum initial is equal to total linear momentum final. And because of V, this is two-dimensional collision actually. So, we resolve at the x and y component. First, at the x component, referring to this principle, we will get that MAUA equal to MA plus MB V cos theta. MA plus MB, because of after the collision, they move together. And V cos theta referring to the resolving V at the x component. And at the y component, we get the equation of MB times with negative UB. Negative UB because of UB is downward before the collision. And after the collision, MA and B move together. So MA plus MB times with negative V sin theta. Negative because of, if you look at the diagram, Vy is downward. So Vy is equal to V sin theta. Negative V sin theta. Substitute the value. To solve this, we have equation 1 and 2, so we can divide 2 to 1 because of sine per cos is equal to tangent. Then we will get the theta first, which is equal to 51.3 degree. When you get the theta, you can substitute in one of the equation. You will get that the velocity is equal to 2.74 meter per second. So because of the question, when you to determine the velocity, you need to state the magnitude and direction. Because of that, it is safe if you write down that V is equal to 2.74 meter per second. below the positive x-axis. Question 3c. A cylinder of 0.5 kg is placed on top of a 1 kg wooden block as shown. You need to sketch the free body diagram and determine the normal force that the table exerts on the 1 kg wooden block. First, you need to sketch the free body diagram. So for the free body diagram, you can sketch either two forces exerted, which is normal force and the weight. But for the weight, you need to combine WC plus WB because of the cylinder is on the top of the wooden block. Or you can sketch separately for the WB and WC as shown. Then to calculate the normal force, to determine the normal force exerted, because of the forces is only at the y component, so total forces at the y component is equal to 0. The object is not moving upward or downward. So the forces is N upward minus with W downward. W is equal to mg. So it is equal to 0. And you can substitute the value mc, mp and also g. You will get that the normal force is equal to 14.72 Newton. Question 4a. A toy car of mass 500 gram travels along horizontal floor under the action of force. Figure shows the graph of F against displacement S. The initial speed of the car is 10 meters per second. First, you need to calculate how much work done by the force over 10 meter traveling. So, to calculate the work done by the force, we refer to the graph of F versus S. From the graph, the work done is represent the area under the graph. Because of that, when you calculate the area under the graph, you will get that the work done by the force is 40 joule. Question number 2. What is the final speed of the car over 10 meter? To calculate the final speed, we will refer to the work energy theorem, where the work done is equal to the change of kinetic energy. For the change of kinetic energy, final kinetic energy minus initial kinetic energy. And we substitute the total work done, and then the mass, and also the initial velocity. So when you calculate, you will get that the V is equal to, the final speed is equal to 16.12 meter per second. Question 4b. A 20 kg load is connected through a smooth pulley to a spring with a spring constant K equal to 350 Newton per meter. Initially, the load is held so that it is at rest and the spring is not extended. When the load is released, determine the speed when the elongation is 0.5 meter. Okay, referring to the figure, assume that before the load is released, the height is h. The height of the load, the position of the load is h from the ground. And then when the load is released, the final position of the load now is equal to h minus x by considering the extension of the spring is x. To calculate the speed, to determine the speed of the load when the elongation of the spring is 0.5, we will refer to the principle of conservation of energy, and initial energy consists only the potential energy of the load because of the load located at a certain height h. And then for the final situation, it is involved the kinetic energy because of the load is moving downward, and then the spring is extend or elongate, so it is involved the half kx square referring to the elastic potential energy of the spring, and also the potential energy of the load, which is equal to mg h minus x. Rearrange the equation and then substitute the value. When you calculate, you will get that the v, the speed when the elongation is 0.5, is equal to 2.33 meter per second. Figure shows a conical pendulum has a small bob of mass 0.3 kg attached to it by a string of length 0.8 meter. The bobs rotate in a horizontal circle of radius 0.5 meter. Calculate the tension in the string. First, before you calculate, you need to sketch the free body diagram. So the free body diagram for this conical pendulum consists of tension and weight. If you look at tension is not located at the y or x component, so we need to resolve to the tx and ty. Now you want to calculate the tension in the string. So we can refer to the y component, where at the y component, total forces is equal to 0 because of the pendulum is not moving upward and downward. The pendulum is only moving in the circular path, horizontal circular path. Because of that, at the y component, we have Ty and W. Ty is representing cos 30, W is mg. You substitute the value, you can calculate the tension in the string is equal to 3.4 Newton. Then you need to calculate the linear speed of the bob. To calculate the linear speed of the bob, we refer to the x component. Because of at the x component, the net force is equal to the centripetal force. Centripetal force is equal to mv squared over r. And at the x component, there is only tx, which is represented by t sin theta or t sin 30. When you substitute the value and also substitute the tension that you have calculated in A, you will get that the V, the linear speed of the bob, is equal to 1.868 meter per second. Okay everyone, we will stop here. I will continue the discussion for question number 6 to question number 8, which is from topic 7 to topic 9 in my next video. Okay, so thank you so much for listening. I wish you good luck and all the best for your PSPM. Thank you.